Hello! This started life as part of a different project, but the hex hole cutting was off on a massive tangent, so I've separated it out as a standalone film. The long and short of it was that I arbitrarily decided I wanted a 4mm hex recess in the end of a piece of rod, even though a simple screwdriver slot would probably have done the job. Without really thinking it through, I set off making a brooch using some 8mm silver steel and a hex collet block. Now my hex will be 4mm across flats, which is 4.62mm across the corners. I began by turning off some of the excess material, leaving it oversize at 5mm. I made this little saddle for the vise to angle my collet block to give me some relief on the cutting edge. I just did this by eye, probably somewhere between 2 and 3 degrees. It took a few goes to work the bugs out of this. I tried horizontal, gripping the flats of the collet block and taking cuts across the job. That didn't work very well. I also tried having the block stood up vertically. But that wasn't very successful either. The best accuracy and repeatability was with the block horizontal, barely gripping the corners. This probably needs a smaller collet block or a bigger vise. This time, the cuts were made by advancing the cutter along the axis of the rod. I took multiple passes, rotating the job after each cut and then dropping the milling head and going round again. Take my advice, rushing by taking too much off at once will spoil it. At this point, the brooch is still a little oversized, but because the tool tapers, the across-slats dimension of the tip can be reduced by making it shorter. I'm going to use a ball-ended milling cutter to leave the end of the brooch concave. At first I used a small cutter, but it left the tip too sharp with too little material, leaving it weak. A larger cutter leaves more meat at the end, which is less prone to breaking. I used the lathe to take a fraction at a time off the brooch, until the end cross-section was about 0.05mm over size. I'd suggest erring on the side of leaving it a little bit big. A slightly loose fit on the Allen key will be preferable to it being too small to fit, and then having to start over. My plan was to hold the brooch in position with a support tube, add the pre-drilled shaft that I wanted the hex hole in, and then put them in the vise and squash them together. It was only at this point that I thought about the actual dimensions. Having spent more time and effort than I planned making the cutter, I didn't want to break it first go. Across flats, my hole needed to be 4mm, so that's the hole I'd drill. A hexagon centred on this hole will be 4.62mm across its largest dimension. That means the brooch would have to cut almost 1/3 of a millimetre of material in one pass, and that's on each corner, a total of 1.86mm. It might work in aluminium or plastic, but I wanted to be able to cut brass or even steel. Even if the cutter survived being pushed in, there was a good chance it would break off when I tried to pull it out again. And I might get away with it once, but I wanted to use it on at least 5 separate parts. Over to Google for some advice. I came across Mike's Workshop and his excellent article on rotary broaching. It seemed quite by accident I'd already made a cutter more or less exactly to his specification, so it seemed sensible to adopt the rest of his method. There's a link in the text to his page and his video. Instead of just forcing the brooch directly in, it's allowed to rotate and is pushed into the spinning shaft at an angle. This means only a small part of the cutter is making contact at a time. As I didn't have any steel large enough, I cut a lump off some 2-inch square aluminium and used the 4-jaw to clean up the sawn face. Next, I drilled a 10mm hole through the centre so it would fit over my tool post stud. After swapping the 4-jaw for the 3-jaw, I used the lathe itself to drill into the side of the block, so it would necessarily be at centre height. It took several passes, and I swapped to Morse taper for the larger sizes. Over on the mill, one side of the block was trimmed at a 1-degree angle to give me an alignment edge when setting the tool. Back on the lathe, I drilled out a steel sleeve, a bit at a time, to 5/16 of an inch. then reamed it to 8mm. One end was tapped M10 to accept a cap head screw. The cap head was drilled to accept a ball bearing, which was made captive with a centre punch. Parting off's usually a disaster for me, but this just goes to show it is sometimes possible with a mini lathe, even in steel. A test fit with a piece of silver steel showed everything looked okay. Finally, the sleeve was glued in place with Loctite. I added a screw and a spring to make the brooch captive in use. This is brass, so it won't mar the brooch. Any burrs made inside the sleeve would make it very difficult to remove. A recess was cut in the shank to match the position of the brass screw. Next, the brooch was hardened. I'm using ClickSpring's boric acid method to reduce the amount of oxidation on the part. A cage was formed from steel wire, the cutter placed inside and then covered in boric acid paste. The part was heated to red. Notice the green flame from the boron in the boric acid paste. It was at this point I realised I was running out of gas. Then the part was quenched in water. The brooch was tempered in the oven for an hour at 225 degrees C. Once cooled, it was given a quick polish in the lathe to ensure a smooth action in the holder. Here I'm preparing a brass rod for a test cut. After centre drilling, a shallow 4mm hole is drilled. Then it's countersunk to slightly wider than the tip of the brooch. A drop of oil and the cutter is driven home. Not a bad result. Whilst trying to broach steel, the cutter failed. Probably a combination of too small a pilot hole, too much cutting pressure, and possibly too much hardness in the thin neck of the tool. It took about 3 hours to get the first usable cutter, but the second only took about 40 minutes. This was tempered to straw by heating the shank rather than in the oven, considerably quicker, and hopefully concentrated the hardness at the tip with a little more give further down. All told, an interesting sidetrack. And that's it for now. Thanks for watching.